Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome everyone to the last subject of our course, which is ITDR2103. The subject is about tree, and it will be discussed on two main sessions, which is lecture 12 and lecture 13. This is Alia, and I'm really happy that we reach the end of this course safely and happily. Now in this session, we will discuss about the tree definition, which is what do we mean by a tree, some terminologies, then we will identify a new one of the trees type, which is the binary tree, and finally we will introduce the tree traversal in order, post-order, and pre-order. All right, now what do we mean by a tree? A tree is a graph that is connected and has no cycle. If we go back a little bit, we can see that this feature is reflecting one type of a graph, which is a simple graph. Now, we already says that simple graph is any graph that has no cycles and they are connected. All right, so a tree is basically a simple graph, and those are the two main rules, which is it's supposed to be in any graph, so we can call it a tree. Let's see this example. This is a graph that has vertices and edges. All right, now if we can see here, we can see that this graph represented the data element where there is a single path between each vertex in this graph. So we can consider this graph as a tree. Let's see this example. If you can see here, there is a cycle. So again, we have like a single path between each vertex here. However, it is a closed path, so we can not consider this as a tree. One more example. We've also got here a vertices and an edges. However, it is not connected. There is no connection between those two vertices, which reflect that also this graph is not a tree. Right? So from here, we can just summarize the rules to call any graph as a tree, which is in a tree, we shouldn't have any loop. There should be no cycles. There should be only one path between any two vertices. And we got here a rule, we should keep it in our mind, which is in a tree, if there are n vertices, then there will be n-1 edges. Okay, so how to calculate the edges in any graph? If we got n vertices, then it should be n-1 edges. And the last rule is it should be connected. Right? Now, let's see this example here. The example says we want to find the number of edges in a graph or in a tree where it has 16 vertices. We've already knows that number of edges in a tree is equal to number of vertices, okay, minus 1. This is our rule. So in order to identify the number of edges, I need to find the number of vertices, and it's mentioned, clearly mentioned here in the question, that we got 16 vertices. Now the number of edges is equal to 16 minus 1. So we got here that this tree has 15 edges. Another example. However, we need to find here the vertices. If I already knew that we've got 20 edges. So again, number of edges in any tree is equal to number of vertices minus 1. Now in here, I've got the number of edges, which is 20, and I need to find the number of vertices minus 1. So in order to find the number of vertices, we will just move 1 to the other side, which will be equal to 20 plus 1. It should give me the number of vertices. So in this tree, we have got 21 vertices. All right, so the number of edges in any tree is equal to the number of vertices minus 1. There you go. Now let's move to the second point of our session here, which is the trees terminologies. Before we introduce our terminologies here, let's just see if this graph considered as a tree or not. First rule we need to check is there is any loop here? We cannot see any loop. Is this graph connected? Yes, it is, because I don't have here any isolated vertex. All right, there is any cycle? No, there's no cycle. So we can consider this a tree, but we need, if we want to make sure, let's calculate the number of edges. So the number of edges in any tree is equal to number of vertices minus 1. And if we can see here we've got 14 vertices. So the number of edges should be 13. So let's calculate here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So yes, we consider this as a tree. However, this tree is organized hierarchical. So if you can see here, we've got level and level and level and level and level. And it started with the very top vertex. So we call this type of tree as rooted tree, where the top vertex in a tree called top node or the root. Okay, then we've got all those vertices under the root. Now any vertex that have a descended vertex can be called as parent. So here we've got parent, parent, parent. And all the vertices under this parent called a child. Or since if we got more than one child, then we can call this children of V2. Okay, so root, we've got here all the vertices under this root. Any vertex that has a descent vertex, we call them as a parent, and those though under the parent, we call them as a children of V2. Now those who are the last vertex in a tree, we call them as terminal node, which means they are the end, nothing under those nodes. Parents also have another variable, another name, which is internal node. All right. Okay. Now we have something called the height of a tree. And height of a tree is basically says the how many levels do I have in this tree. So here we got 1, 2, so we can see this. 1, 2, 3, 4, and 5. So we can say that this rooted tree is of height 5. Okay? So it's really important you understand where is the root, where is the terminal node, who are the parents, and what are the children of those parents, and the height of the tree. Now a rooted tree is basically the tree which is particular vertex is designed as the root, which is the first or the very top node. Level of a vertex is the length of the path from the root to V, or the number of edges from the root to V, which is a terminal node. Now if we go back here, we can see that the level of this root tree is the number of edges from the first node, which is the top node, until the last terminal node. So we can see here 1, 2, 3, and 4. So the level of this tree equal to 4. And if you notice here, level is basically equals to height minus 1. Okay, we have a definition here. Let T be a tree with V0 as a rooted and V0 E1, V2, V1 E2, V2 until Vn is the path in T. Now Vk is called a child of Vk minus 1, and this is what we mentioned here. V5 is a child of V2. V12 is a child of V5. Okay? If a vertex V of T has no children, then V is called as terminal vertex or a leaf. If V is not a terminal vertex, then it's called as internal vertex. And this is what we mentioned earlier in our rooted tree. We got terminology, he says, descended. Now, if T is a rooted T, then U and V be distinct vertex in a T. Then V is said to be descended of U if U and V are on the unique path from the root T to V, and U appears before V on this path. So descended is when I have two vertices, one, which is U, appears before V. Ordered rooted tree is when we've got a rooted tree, but the children are assigned in a fixed order. And we will see this in our type, which is the binary tree. Height of a tree is the number of vertices on the longest path from the root to leaf. So you need to distinguish between the level and the height. Level is number of edges on the longest path. Height of a tree is number of vertices on the longest path. All right, that's why the relationship between height and level is usually equal to height of a tree minus 1. Okay, now if we go back to our tree, we need to find the root. So the root of this tree is, if we say this, 1, 2, 3, 4, and 5. Now the root of this tree is V1. Level of vertex V6 and V3. Now V6, we say level is the number of edges. So the number of edges in a path from the root until the certain vertex. So V6, we've got V1 going to V2, and here we've got V6. Now how many edges from V1 to V6? We've got 1 and 2. So the level of V6 is 2. How about V13? Again, we will check the path from the root until the certain vertex, which is V13 in this time. So here we've got 1, 2, 3, and 4. So we can see that V13 is in level 4. Now we need to find the child of V2 and V9. So we go here. The child of V2 are all the vertices under V2. So here we got that the child of V2 is V5. Okay. V6, V7. Child of V9 is none, 0. So V9 is a leaf node, terminal node. It doesn't have any children. Descendant of V5. What do we mean descendant of V5? We mean that all the vertices are under V5. So if we can see here, the descendant of V5 are V11, V12, V13, V14. The descendant of V4 is, we have like this, so we can know that we are doing the other. Okay, the descendant of V4 are V9 and V10. Finally, the height of the tree, which is the longest, the number of vertices in the longest path in the tree. So the longest path from V1 to V14, and here we got 1, 2, 3, 4, and 5. So the height of this tree is 5. All right. Now, one type of a rooted tree is called the binary tree. Now, a binary tree is an ordered rooted tree, which is either it is an empty graph or each vertex has no child, one child, or two child. So, a binary tree, or we called as an ordered rooted tree, each vertex, if it is non-empty, then it can have either 1, or 2 or no children at all. Okay, now an example here, we've got this, consider as a binary tree. Here we got A, B, and C. We can consider this as a binary tree, A, and then B, C, and here we got D, E. Each parent can, here we've got C with no children, and here we've got only one, and here only one. And one more example is if we got here A, then B and C, then we have here F, H, and here we've got 2, E and D, and here we've got G. So binary tree is when we have an ordered or rooted tree where the parent can have either 2, 1, or no children at all. Okay, so since it is dividing each parent to only 2 child, we can divide a binary tree to 2 main subtree. See, we've got here any binary tree can be divided to 2 main subtree. We call the one in here as right subtree, and the one in the side called as left subtree. So here we've got left subtree, and here we got the right subtree. Okay, another definition here, we've got the full binary tree. So the full binary tree is a tree. However, each vertex has either 2 children or no children. Example, this consider as a full binary tree. This also consider as a full binary tree. Here we got, EF. Here we got 1, 2, 3, then 4, 5, 6, 7. And this is called a full binary tree. However, the order here is not right, because in a binary tree we have something special which we will identify in the next session, where we'll discuss about the binary search tree. Now we have something called the binary tree traversal, and binary tree traversal is basically the processing of visiting any tree node exactly one in some order. So if we got a tree, okay, and we have those names A, B, C, D, and E. Now we consider this a binary tree because each vertex has either 2 or 1 or no children. Okay, now the tree traversal is the way we are visiting those nodes, and we have 3 traversal here. The first one, which is called the in order or in order sequence. And in order sequence, if we got the tree as what you can see here, root, then I have left subtree, and we've got right subtree. So in order traversal, we usually visit first the left subtree, then root, then the right subtree. Okay? In order traversal, we usually visit the left subtree, root, then the right subtree. In pre-order, we do not do it like this. Let me just... Okay. In pre-order traversal, we usually, if we got root, left, and right. So in pre-order, we first visit the root, then left, then right. And the post order is where we have a tree. So we first visit left, then right, then root. Okay, so it's really important to know the order. In order, left, root, right. Pre-order, root, left, right. Post order, left, right, and root. And I will show you a technique to do the traversal. See this example here. Let's suppose we've got this tree and we need to list the vertices of the minor tree in order, pre-order, post-order. And we can either use this description here, left, root, right, root, left, right, root, or we can check the trick, what I will show you now. For the in order, all what we do is we will draw a flag under each vertex. So here we got a flag. And all what we do is we will visit the vertices or the node of a tree starting from the left to the right. Okay, like this. Whenever we hit the flag, then we write the node in here. So if we go like this, then we got here, we hit it B. Then we continue, then we hit D, then we go and we hit A, and then C. Now the in order traversal for this tree is B, D, A, C. Or we can have it as left, root, right. Left, we finish BD, then root, then right. Okay, how about if we got the second one, which is the pre-order? In the pre-order, we will draw we will draw the flag on the left. So we'll have it like this. Whenever we hit the flag, we write the note. So here we got our first hit is A, then B, and then we go to D, then C. So for pre-order, we first visit the root, then left, and then right. Okay? Third one, which is the post order. We will draw the flag to the right. So we'll have it like this. Whenever we hit the flag, then we just write the node. So we start like this. So we go, then the first node headed here is D, then B, then we continue until we hit C and finally A. So here we first visit the left. Sorry, we should write it as what you said here. Left, right, then last thing is the root. So left, D, B consider as a root. So each subtree consider as a root. So here we got B as a root, then we suppose if we got here a vertex, then we have left and right. So here we first visit left, nothing in left, right, then root. Then here we can again left nothing, then right nothing, then we go straight forward for the root and A also. Okay, here we have a blank place just to make sure that you got the trick. We will draw this tree. Okay. So here A, B, C, D, E, and here we got G. For C we have F and H. Here is the tree is quite complicated because each, as we said, each subtree is a root left and right. Okay, so if we start by visiting the post order. In the post order, we already says that we usually draw the flag to the right. So we will draw a flag here to the right and we'll start visiting the node from left to right. So the post order of this tree is, if we go like this, the first thing we hit is G, D, E, B, then we continue to the right subtree, H, F, C, and finally A. So here we first visit the left, then right, then root. Okay, now let's check the pre-order. And pre-order, we says the flag will be to the left. So we draw it like this. A flag to the left. So we will start with the root A, B, then D, G, E. Then we continue to C, F, H. So in pre-order, we start with root, then left, then right. Okay? The last one, which is the in order. In order, we have the flag in the middle. And the first node headed, then we write it. So here we can see that if we just go like this, we will start with D, G, then B, E, A, C, H, and F. So here we basically mention the left, root, and then the right. Now, if you go back to the course material you've already got, you will have some exercises just to check that you got understood. What do we mean by a tree? The tree traversal and the binary tree. And here we reach the end of this session where we introduce the definition of a tree and some terminologies, and then we just define a binary tree, and we introduce also the tree traversal, which are in order, remember the flags, post order, and pre-order. Thank you for listening. We'll see you soon in the next session, inshallah.